Let's review how to solve multi-step equations. We're going to look at two kinds. We'll look at some that have just variable on one side, and then we'll look at an example that has variables on both sides. So let's start with when all the variables are on one side. So one example would be, let's say I've got this equation. Okay. So our goal is to look at each side as an individual problem almost, and let's focus on the left side and the right side. On the right side is plain 18, nothing I can do with that. That's as simplified as it's going to get. On the left-hand side though, there's a couple ways we can do this. I'm going to choose to do distributive property first. That is not the only way to solve this. It is one of the ways. So I'm going to choose to go ahead and distribute this 3. So 3 times x is 3x. 3 times negative 3 is negative 9. And I'll just drop down the equals 18. Just as a comparison, I'm going to do the same problem again, but I'll solve it a different way, just so that there are more than one possibilities to solve. You don't have to do it the same way. So in this second round, I'm going to choose to, instead of distributing, this 3, when it's right outside these parentheses, that means times. And we undo multiplying by dividing. So I can divide by 3, but if I divide my left side by 3, then I have to divide my right side by 3 to keep it balanced. And 3 over 3 is 1, so that essentially cancels. And I just have x minus 3 on the left. And because there's nothing else there, I no longer need those parentheses. And on the right, 18 divided by 3 happens to be exactly 6. And then let's just go ahead and finish this method. So the opposite of minus 3, I'm going to add 3 to both sides. That's 0, so it cancels. X equals 9. And let's go back over to the left-hand side here, and let's continue this one. So here I am with this step. I'm down to a two-step equation now. And we're dealing with a two-step equation. We want to first undo addition or subtraction before we worry about dividing. So this 3 times x I'll handle last. So I'm just going to drop that down in a second here. I'm going to handle this minus 9 first. The opposite of minus 9 is going to be to add 9 to both sides. And that's 0, so that cancels. So I have 3x on the left-hand side is equal to 27 on the right-hand side. Now I can get rid of this. This is 3 times x, and to undo multiplying, we divide on both sides. So x equals 9. So either way, we get the same answer. Two different ways to solve it. So it depends on which way you understand better. It makes more sense to you. Choose that way. Okay, we'll do another example just with variables on one side. So let's say we've got something like equal to negative 18. All right, so this one's similar, but this one has this thing added here, this plus 2x on the outside of the parentheses. So unlike the first example, we could divide by 3. I can't do that right away because it's only this part here that's being multiplied by 4 and not the whole side. So this only worked up here in this problem because this entire left side was being multiplied by 3. That's not true down here in this new example. So in this new example, I'm not going to be able to do that same first step. So instead, I'm going to go ahead and do that distributive property like I originally did. 4 times x and 4 times positive 3. Then I'm going to drop down everything else. Drop down that plus 2x I haven't used yet, equal to negative 18. So just like the first one, I've got this negative 18 on the right-hand side. There's nothing I can do with that. But on the left-hand side, I can do a little bit more. I can simplify because I'm noticing I have a 4x and a 2x, a positive 2x. Those are like terms, and I can combine like terms. 4x and 2x makes 6x, and I'll just drop down that plus 12, and then on the right-hand side I still have that negative 18. So again, I'm treating these like two separate problems. I'm treating that left-hand side like its own problem, and distributing, combining like terms, trying to simplify that as much as possible. Now there's nothing else I can do on the left because there's no more like terms. There's nothing else I can do on the right because it's just a plain old number. So now I'm going to start solving. And I'm going to undo my addition and subtraction first. So I've got a plus 12, the opposite is to negative or minus 12. So we get 6x on the left is equal to, be careful with integer rules here, we're doing negative 18 minus 12. A very common mistake is that we want to put this in our calculator. We want to put in negative 18 minus negative. We don't have that here. We have a negative 18 and a negative 12. We don't have two minus signs here. So if we are putting this in our calculator, then we are putting in negative 18 minus 12. So careful with the extra negative signs when you're doing that. And we should get negative 30. And now I can finish solving. The opposite of multiplying by 6 is to divide by 6. 6 over 6 is 1, so that cancels. So x is equal to negative 5. Okay, we're going to look at one more example, and this is going to have a variable on both sides. And it's going to be really similar to what we were doing there. So let's say, let's look at a problem where we have some more simplifying to do also. Okay, so like the very first one, this entire side here is being multiplied by negative 3, so I could divide this entire side by negative 3, but then I'm going to end up with some fractions, some decimals. So I'm going to choose not to do that because I want to avoid those extra fractions if it's not necessary. So instead, I'm going to leave this left-hand side alone because 7x minus 2, there's no distributive property, there's no like terms, so there's nothing else I can do with that. But on the right-hand side, I can do some distributing. Negative 3 times negative 2 is a positive 6. And negative 3 times a positive x is a negative 3x. Or if it helps, anytime you have a variable like x with no coefficient, I can always put a 1 in front of that if that helps. Now, there's nothing I can do here, there's nothing I can do here, so now I'm going to start solving, and that means moving things around. So if we look up at this problem up above, I had variable on the left and constant on the right, because that's what my answer looked like, variable and constant. So I need to get, on my new example, I need to get variables on one side and constants on the other. I tend to just move my variables over to the left, but that's not the only way to do it. So if I do that, then I want to get rid of this minus 3x and move it over to the other side. I'm not trying to separate the 3 from the x. I want to keep that 3x together. I just want to move this whole thing over to the other side. So when I'm trying to move a whole thing over, I am adding and subtracting. And it's a minus right now, so I need to plus or add 3x. And I'm going to put it on the underneath its like term on the other side. It's going to be 0, so it cancels from this side. And 7x plus 3x, so now I've got a 10x over here, plus I've still got that minus 2 is equal to, now I've just got a 6 left on the other side. So I'm getting closer. All my variables are now on the left, so I'm going to move all my constants over to the other side. So I need to move this minus 2 over to the other side. And the opposite of minus 2 is plus 2. One's on the left and one's on the right. That's 0, so it cancels. So I have 10x is equal to 6 plus 2 is 8. Now there's not much else I can do, but this 10 is still attached to the x. Now I want to actually separate that. So now I'm going to do my division, because the opposite of multiplying is to divide by 10 on both sides. So x equals, you can just leave it as is, 8 over 10, or you can divide that and say x equals 0.8, or you can reduce that down. I can divide them both by 2, 8 divided by 2, 10 divided by 2, and I get 4/5. So I would take any of these answers would be equivalent.